Hello, my name is Danny Nowlan and I'm the Director of ChassisSim Technologies. In this video tutorial, we're going to be talking to you about a relatively new feature in ChassisSim that's actually starting to find traction out there in the ChassisSim community. And what I thought we would do today is we'd basically outline what this new tool is. I'm going to give you a bit of a theory background on it, and I'm going to show you how to apply it. Now, this tool, this tool is something called setup referencing. And really what it is, it's a tool to aid in the sensitivity of your models. Now, what are we going to do? What in particular is setup referencing, and why do we need it? Well, the motivation comes in the fact that current time models, 2D models in particular, and what I'm talking about is where you have traction circle radius plotted against load. So what you would have in the ChassisSim 2D time model representation, a Pajaca model, and other such empirical and other types of empirical time models where you have traction circle radius versus load do a pretty good job of representing a setup particularly well. And this is a typical 2D model correlation you can see that's been produced with a ChassisSim plot. The problem is what they lack is sensitivity, and really this boils down due to the nature of the time model. Let's illustrate this with an example. What I'm going to do here is illustrate this with a typical example of a V8 supercar. Now, in reality, I could have used any other race car to discuss this, but I'm going to use the particular example of a V8 supercar basically because I'm going to be discussing a well-known tire change that produces a noted impact. So typically we've got the initial coefficient of friction of about 2.2 and a peak load of about 850 kilograms. So what we've done is we've shifted a typical Pajaca model to this where coefficient of friction drops off linearly with load. Okay, so let's give it a 10 mil rear roll center change. So what I've done is just to fill you in, I've typically gone with a typical baseline supercar setup, and I'm basically doing a rear roll center change from 240 millimeters to 250 millimeters. And it's really interesting if you go through and look at the tire loads, take a look. The difference between the difference between the front tire loads and the rear tire loads, when we take a look at the deltas, is barely about 3 kilos in terms of load. And as we can see, if we just do a simple force balance, this gives us a difference of about 0.2 of a kilometer an hour. So you'd think on paper this shouldn't be terribly much of a change, yet in reality when we apply this to, or when we apply a 10 mil rear roll center change to a V8 supercar, that is something that the driver can return back as a discernible field difference. Now, in reality, what the driver will report and to what actually happens, as we all know, any practicing race engineer worth their salt will always know, there will always be a little bit of a disconnect between the two. However, if you take a look at typical V8 supercar parlances, your rear roll center change is one of the most sensitive adjustments to these cars. So as you can see, like with all things, the truth is going to lie somewhere in the middle between what we've discussed in our table here, where we've predicted a 0.2 of a k an hour change, and to a driver swearing black and blue that a 10 mil rear roll center change transformed the car. Now, what's going on here is that tire force versus load characteristic is greatly influenced by the internal pressure and temperature. Now, this is something that anybody who spent more than 5 minutes playing with a real race car is going to know by heart, because one of the first things you do when a race car comes in to the pits is one of the first things you do is you take tire pressures. And that is no accident, because there's a very, very narrow band of hot running tire pressures where the tire is going to work. But um, uh, but also too, as we have found with research done by organisations of the like of Michelin, in particular in their TAME tire model, part of their tire formulation is they have coefficient of friction as a function of internal tire temperature as well. And if we take a look at that, we've got a simple schematic of our tire. We've got cords versus structure. We've got the rubber compound. And as you can see, the internal tire pressure and internal temperature is going to have an impact on what the coefficient of friction is doing, and also it's going to affect things like your contact patch length variation and the knock-on effects that's going to have. So consequently, as you start making tire setup changes, you're going to also influence those internal tire pressures and temperatures, and that in turn is going to have a knock-on effect on things like your tire model, in particular the traction circle radius versus load characteristic. So where does setup referencing fit into this, and how does it work? Well, what setup referencing is, and the whole idea behind setup referencing, is that it's an approximation of this phenomena that we discussed in the slide previously. And so what we're going to do is our first step is we're going to associate a tire model with a particular setup. And to an extent that makes sense, because if you really look at it in its most pure form, when we run the tire force estimation toolbox and the tire force modeling toolbox within ChassisSim, what we're doing is we're taking a snapshot of what that tire was doing at that particular internal temperature and internal pressure condition. So what we're doing with setup referencing is our first step is to associate a setup with that particular tire model. I'm going to walk you through how to do that very shortly. Then what we're going to do is we want to plot tire pressure variation versus tire force variation. And the way we do this is there are a number of ways you can do this, but probably the best way of doing it is to get your particular setup, run at your hot tire pressure variations, and then knock off tire pressure deltas. Now this can be in the order of about half a pound, depending on the sensitivity of your tires. For example, for something like an open wheeler or a very, very tire pressure sensitive tire, you might only use about 0.2 of a PSI per step. Or with something, say, like a saloon car, you might go half a PSI, a pound PSI. A lot of it's going to be dictated. But as you can see, the delta force factor can actually be very readily determined from data where you've got AY current minus AY reference on whatever axle you're looking at here. I've illustrated the front weight distribution, or weight distribution of the front times your AY reference. Now, when you're done, you're going to wind up with a curve that looks like this. And on the horizontal scale, we've got tire pressure and PSI, and we've got force factor plotted against that tire pressure sweep. So really, that's what we're going to use that's what we'll use our data for. And you'll find and even if you never use this in Anger and ChassisSim, it still is a worthwhile exercise to work through, because it's going to give you a really good sweep of really where those tire pressures should be kicking in. What we then do is we then assign our setup to this, and then you can see here that we've got our internal pressure multipliers. And what we're doing is that for our big ticket items, things like roll centers, pitch centers, spring rates, bar rates, and third spring rates, if it's applicable for your setup, is obviously the stiffer you go, the more load you're going to be driving into the tire, the more temperature you're going to be pushing up. Hence, that's what this internal tire pressure multiplier represents. So the bigger you go, the more sensitive it's going to be to a change, the more it's going to increase the internal tire pressure, and the more it's going to push your force factors around in this particular region. Effectively, when you're using ChassisSim like this, you're effectively using ChassisSim as a calculator to try and approximate internal temperature heating. Now, I realize that there might be some people listening to this who might recoil in horror about what we're doing here. Just remember, what this is an approximation. And before some of you get before some of you get too upset with this, just remember an awful lot of CFD that goes into calculating commercial airliners actually ignores air viscosity. So, which is in fact the sticking which is the stickiness of air. So just remember what we're doing here is this is an approximation. Now, some conclusions and reflections. Where setup referencing sort of dials in is you need it when you need to dial in sensitivity, when you need to dial sensitivity in the model. In particular, one of the things that we've been finding is that some of our customers have really been using this to dial in what they to dial this in as a tool to replicate front roll center sensitivity on an independent front end. That being said, like with everything, this is a tool that needs to be used in moderation. And what I mean by that is, yes, the results can be good, but it can be very, very easy to get carried away by making this curve look funky to try and appease drivers. Just remember, at the end of the day, ladies and gentlemen, we are not in the appeasing drivers business. We are in the business of making the race car go faster. So consequently, always when constructing this curve, make sure you do a proper tire pressure sensitivity sweep and make very, very sure that you're tuning in you're tuning in this table here to what the draw to cross-referencing it, what you can to what you can see in your data. Now, in reality, this is very much sort of a placeholder until we in ChassisSim have it can get a reliable representation of internal tire pressure and temperature. Now we've currently got that under development, but obviously it's not at the point where we can sort of release it into the wild yet. That being said, one of the things we have found is that this setup referencing technique is a very good approximation to get you going and to get you in the ballpark, in particular when you need that setup sensitivity. But the operative word here is don't overdo it. So let's now talk about how you tune. Let's now talk about how you tune this in with ChassisSim. So what you do is in standard mode is that you click on your tire and you go to you go to your edit thermal properties. First things first, you want to fill in this traction circle radius multiplier. So typically this is for an F3 car, so I'll start off with about 0.8. I'll aim for a hot running tire pressure at about 22 psi. And what I'll do is I'll just linearize to that point. And beyond that, let's just say it crashes. I might just give it, say, another 0.8. And I linearize again to that point. Now, I realize this is a bit of a simple example, but it illustrates the process. So that's the first part of the process. But once again, let me stress, this comes from doing a pressure sweep on your tires, making sure that you've recorded that AY delta force factors correctly and accurately. And if anything, I would also advise to use a frequency-based filter when looking at that data, so that way you can see some clear trends as well. Once you're done with that, you then go to assign setup reference properties. Now, let's just say that you've done your tire force optimization on that particular tire. You click on assign reference from current setup, and what this does is this goes through and assigns your current setup, and then you fill in your multipliers as they're required. So I might put in, say, a roll center multiplier there of 20. For your tire pressure, that might be 1. For your pitch sensors, let's just say for our pitch centers, that might be 10. And for our spring rate, this may be in the order of about, say about 5. Roll bar rate, this might be about 5 again. But once again, you're going to tune that in to what the car wants. And once again, cross-referencing what you'll hear from the driver, but what you also see in the data as well. So this is a powerful tool. But let me stress again, to use this with caution. So to activate that feature, you basically click on Incorporate Setup Reference and Tire Pressure Calculation, click on OK, click on OK here, click on OK to commit that, and you are good to go. Now, some parting words of wisdom here. First things first, when you're doing your tire modeling, I would strongly suggest that when you're clicking on your thermal properties, make sure that your setup referencing is off. So you want that off to start with, because what you're and we make sure that we've dialed in the appropriate hot running tire pressure for that tire force optimization. Because just remember that tire force modeling or tire force estimation is taking a snapshot of the tire. Once you're done with that, you then go through and construct your experimental curve. You then go and construct that experimental curve. Once you've done that and you've entered that by clicking on thermal properties, traction circle radius, pressure multiplier into ChassisSim, that's when you start to play with setup referencing. So for those of you who are ChassisSim users, I'd encourage you to have a play with this. Now, start slow. There's no need to rush this or to overdo it. Remember, it is the cherry on top. It's like it's applying the magic sauce and the magic mayonnaise to your current tire model. Because the thing about your 2D tire models is that yes, they do point you in the right direction, and they're very good at doing that. But just remember, the deltas are always going to be, the deltas though for your pure 2D tire models, and even for some of your 3D tire models, will be small. Now, that's for two reasons. Number one, the fact that ChassisSim is the perfect driver, but also two, the reason they're so small is that for the range of setup parameters we're looking into, if you go through and calculate your lateral load transfers, you're dealing with deltas of about 0.1, 0.2, maybe 0.3% max, which is deltas in the order of 4 or 5 kilos. So consequently, you'll always have small changes in tire force. Now, if that's what the car is doing and what it responds to, great. You don't need to play with setup referencing. But if your but if you'll find that your car is actually showing that increased sensitivity, chances are those internal tire pressures and temperatures are coming into play. And this is what we can approximate with setup referencing. Now, in closing, setup referencing isn't perfect, and I do not pretend that it is perfect. And anybody who pretends that it's perfect is quite frankly lying to you. That being said, we have found it to be a useful approximation in showing setup direction. So have a play, see what it is, because ultimately though, if it doesn't work out, you can always go back here and make sure it's turned off. That being said, we have found that setup referencing is starting to be used within the ChassisSim community and is actually proving to be quite a useful tool. So without further ado, if you are an existing ChassisSim user, throw some mud in the wall, have some fun, and find this out for yourself.